Hi everyone. This project looks at a simple but important question in sustainable construction. Is construction cost actually related to embodied carbon? And more importantly, can cost be used as an earlier indicator for environmental impact? In sustainable construction, one major challenge is balancing between economic cost and environmental impact. Every building material has an associated price and an embodied carbon footprint. That is, the greenhouse gas emissions released during its production. However, designers or engineers often make decisions without qualitative insight into whether cheaper materials actually emit less carbon, or if low carbon choices come with higher costs. My project used data analysis to explore whether there is a measurable correlation between construction cost and carbon emission among common building materials. So the core question for this project is very straightforward. Is there a qualitative relationship between construction cost and embodied carbon? And if there is, how strong and reliable is that relationship? The dataset is adapted from the Inventory of Carbon and Energy database created by University of Bath and combined with approximate market prices. It lists materials such as concrete, timber, and steel, along with their average embodied carbon per kilogram and estimated construction cost per cubic meter. Here is the small screenshot showing several sample materials. So here, I'm looking at the relationship between construction cost and embodied carbon intensity using like one graph. On the x-axis, it's about embodied carbon per cubic meter, and the y-axis is construction cost, and also per cubic meter. So all materials are directly comparable. When we take the first look, there is a clear positive trend. Materials with higher embodied carbon generally tended to be more expensive. The fitted trend line gives an R-square value about 0.77, which suggests a moderate correlation. However, what's important is that the trend line is how the points are distributed. Instead of forming a smooth linear pattern, the data clearly clusters by material type. Timber materials appears in the low-cost, low-carbon region. Concrete and brick sits at relatively low cost but moderate carbon levels, while metal from a distinct high cost, high carbon group. This suggests that the observed correlation is largely driven by material catalog and production process, rather than cost being a directly predictor of carbon emission. After that kind of the figure, I applied a simple linear regression model to further examine the relationship between the cost and embodied carbon. The model produces a moderate R-square value, which at the first suggests a reasonably good fit. However, R-squared alone is not sufficient to evaluate model validly. So I looked at for the residuals part. In this plot, the residuals are not randomly scattered around zero. Instead, their magnitude increases and embodied carbon increases. This pattern shows that the variance of residuals increases at higher embodied carbon values. As a result, even though the regression shows a kind of like a relationship of correlation, the model does not reliably explain the relationship between different materials types. This significantly limits its predictive power. The analysis shows that the embodied carbon is primarily driven by material catalog and production methods rather than cost alone. Recycled metals demonstrate significant carbon reduction with relatively small cost differences. Therefore, construction cost is an incomplete and potentially misleading indicator of environmental performance. In conclusion, relying on cost is a proxy for environmental impact can lead to misleading decisions. Embodied carbon need to be exactly integrated into earlier design workflow. Even with a simplified database, this project shows how data analyzed can support more informed and sustainable material selection. Thanks for watching. I'm looking forward to receiving any feedback and continue this exploration into data-driven sustainable construction.